in Exam 2 Retake, and I'm going to use a lot of the information from Exam 2 solved in the previous section to sort of guide my solutions here. So for example, for question number 1, this object is going forward and it's slowing down. And I know that because the slope of the curve is leveling off to a flat shape. So the velocity versus time graph of this object, I start off going fast and forward, and then I slow down to a stop. So choice B is the natural answer. Continuing on, question number 3. What is the object in this velocity time versus time graph doing? It's starting from rest and it's going backwards faster and faster. So let's see if we can find something that says that. Speeding up from rest, that's the closest we get to the right answer. Now what's happening in this graph, I start off going forwards and fast, slow down to a stop, and then start going backwards faster and faster and faster. Which answer captures that idea? Well, let's find out. Starting from position in the negative direction of the reference point, passing through the reference point. Well, we need the idea that it stops, and I'm not seeing that in this choice. You see, it stops right there and then it speeds up again, and I need some choice that'll capture that idea, and that seems to happen right here in choice E. Now, which of the following is the velocity versus time graph for an object that's moving the negative direction and slowing down? Right here. I start off going negative direction and I'm going slower and slower and slower. Remember, when you're at the 0 point, when you're on this axis, the time axis, you have velocity versus time anywhere along this axis. There, that's 0 speed, 0 velocity. You're standing still. Now, here, let's assume downward direction is negative and answer some questions. So, I throw something vertically upward with a velocity of 20 meters per second. The acceleration is going to be about negative 10 meters per second squared. Again, that's 9.8 meters per second squared, really. Now, the velocity of the object after 1 second, well, let's go ahead and do that. So we have v equals negative gt plus v naught, which is 20. So we have v equals negative 9.8 times 1 plus 20. So that gives me v equals about 10 meters per second. So that is, in fact, choice D. Right there. Now, the velocity of the object 3 seconds after it's thrown, let's go ahead and do that. V equals negative 9.8 times 3 plus 20. And when I actually do that, that actually ends up being, let's see, I think that actually ends up giving me negative around, I'm just going to round here, around negative 10 meters per second when I work that out, because I'm going downwards. Now, let's figure out what these situations are talking about here. An object's position is increasing at a decreasing rate. What that means is I'm starting off going forward really fast, and then I'm slowing down as I go along. So what describes that? I'm going positive, but I'm going positive at a slower and slower rate. That would happen if I rolled a ball uphill in the positive direction. An object has negative velocity with positive acceleration. That actually means that I'm going backwards and slowing down. So let's see if we can figure out what captures that. So a person is running backwards and is slowing down. That's actually choice E right here. Okay, so now an object is moving in the positive direction with a negative acceleration. Again, I'm going forward and I'm slowing down. So that's choice A. At 12, a good model rocket can reach a height of 500 meters with a hang time if we ignore air resistance. That's kind of funny. I think we actually solved this problem. Let's just double check and make sure that we get it right. So we have y equals negative 1/2 gt squared plus 0 times t plus 500. And of course, this should actually be 0 here. So I'm going to get 500 equals negative 4.9 times t squared. And that's going to give me about 10 seconds for t when I solve. So I'm going to get, again, t squared is about 100. So that means t is about 10. Close enough. Now, in that video, we saw Jordan Farmer had a hang time of 0.84 seconds. How high did he jump? A lot of people made a mistake with this. You have to have the hang time to get the time that you actually spend either going up or going down. So let's get the time he spends falling. use that as the time that he spent falling, calculate how high he fell from, because that's how high he jumped to. So we have y equals 1/2 gt squared. It's kind of like this rocket equation here, so I'm just going to leave out the rest of it, plus y naught, which we don't know. So we have 0 equals negative 4.9 times 0.42 squared. So let's go ahead and get that number. And if I'm right, I think we have 0.86 as our answer when we go ahead and calculate that, which I'll actually go ahead and do now. So yes, that is the right answer. Now, next question. Starting from rest, a vehicle accelerates in a straight line road at the rate of 4.0 meters per second squared for 5 seconds. We want to know the speed of the vehicle at the end of the time interval. So v equals at plus v naught, and that's going to be v equals 4 times 5 plus 0, and that's going to be 20 meters per second. Very good. Now, the total distance the vehicle travels in this time interval, let's see, so that's going to be x equals 1/2 at squared plus 0, x equals 1/2 times 4 times 25, and that actually ends up being 50 meters, if I've done that right. So 5 squared is 25, yes. Acceleration is 4, 1/2, yes, so 1/2 times 100 is 50. Good deal. So now we have some free response questions to do, and if you notice, they were totally different than what you've seen on the previous exam, and that's just something I like to do for retakes. My belief is that that your original exam is not practice. You're supposed to deliver. So if you're going to get to do a retake, you've had one exam, you're expected to talk to other people and figure it out. You're supposed to learn the stuff in class, not after the class, like during the class and studying. And then when you take a retake, I've kind of decided as the year goes along to make the retakes really hard to sort of encourage you to try to get it right the first time, and I think that's fair. So we have this same problem with the police car and the speeder, but now we're going to have the police car accelerate from rest. So this is my bad police car, and this is my speeder, and let's see. So the way this one's going to work is we're going to have, you know what, I don't want to actually do that. I want to do it with axis that looks like this, right? And here's what happens is that we have the speeder going like this, and we have the police car actually speeding up to catch up to the speeder. And that's kind of what happens. So this is the police, and this is the speeder. And that's kind of what happens with that. So there we go. You know what? I just want to move all this over. So I'll just do that, and we'll continue on our merry way. Like, whoops. Like this. So our speeder graph, yeah. So that's what happens here. That's what our graph looks like. Good. Now we want to determine the time they meet, the distance the police car has to travel to catch a speeder. So I kind of based this on the first exam that you did. So you've got to actually kind of do a lot more legwork on your own. So let's take some data and actually do this. So x of the police car is going to be, well, the initial speed is 0, so it's 1/2 times the acceleration, which is 5 times t squared. And for the speeder, well, he's already going, and he's going at a constant rate, so that's going to be 40 times t plus 500 when I set up its equation. So what we're going to do is we're going to do what we did in the first exam. So if you look at the first exam and the first exam retake, look at how I solved that problem if this confuses you. I'm going to set this equal to this and solve for time, and then I'm going to go back, plug in, and get position. So here we go. I'm going to get 2.5 t squared equals 40t plus 500. So I'm going to get negative 2.5 t squared plus 80t plus 500 equals 0. So to get the time, what am I going to have to do? I'm going to just do something here because I just like to do algebra when I can to make my life simple. So I'm going to multiply everything through by 2. If you don't know what I'm doing, I'm sorry, I can't reteach Algebra 1. So this is 1,000. I'm just multiplying everything through by 2, and then I'm going to divide by 5. So I'm going to get negative t squared plus 80t plus, 160 divided by 5 is not 80. So let me just redo that. I'm going to divide by 5, and I'm going to get negative t squared plus 160 divided by 5, so that's 3 times 5 is 150. 3, 5, 15. 32t plus 200 equals 0. So that should be right when I multiply that out. So now what I want to do is go ahead and solve for the time using the quadratic formula. So the way I'm going to do that is I'm going to get t equals negative 32 plus or minus the square root of 32 squared minus 4 times a, which is negative 1, times 200, all over 2a. So that's 2 times negative 1. So I'm going to get t is negative 32 plus or minus the square root of, and I got to simplify all this out. So I'm going to go ahead and do that and just multiply a few things out, and I will get the answer for the time, and that will be, and actually I'm going to simplify the square root. So this will be negative 42.7. Sorry, let me make sure I have that right yet. So this should be positive 42.7 here. So the answer is going to be right is so plus or minus 42.7. So when I simplify all this out, I want to get the positive time as my answer because negative time doesn't make any sense in this problem. So this ends up being negative 74.7 divided by 2. And finally, I can get my answer, and that will be negative, let's just do that. That'll actually end up being positive. So yeah, it's negative. So negative over negative, 37.35 seconds. And then I can go ahead and get the position from that. So I'll get the position that they meet is going to be 1/2 times 5 times 37.35 squared. And they actually meet up at looks like about 3.5 kilometers is what I'm getting. So about 3,487 meters away. So that's how we do that one. Now, let's see how much time we have left. So what I'll actually do is I'll stop this video now, and I will finish the rest of the problems in the next video.